This here. Okay, I got a sentence for you. Are you guys ready for this?
No. I need a.
Oh, come on now.
I need to fix my head.
Oh yeah. All right.
Okay,
Well,
T.
I'll let you catch up. Okay, John.
Yeah.
Inequalities.
I lost this. 2 again.
Inequalities are solved using inverse operations, which is what we did to solve equations. Oh, actually our sentence says just like equations. But, okay, so inequalities are solved using inverse operations, just like equations, but with some special considerations. And you're going to find out what those special considerations are today. Okay, are you guys ready to do some of these? The instructions are to graph the solution. Graph the solution. And maybe I should add to that, I'm sorry. Graph the solution on a number line.
Graph solution number 1.
Because if you're asked to graph this on a coordinate plane, it would be different work that you would have to do. So we're going to graph the solution on a number line. And our first example is x minus 5 is less than negative 3. Well, you're basically just going to pretend like it's an equation and do properties of equality, right? To keep it balanced on both sides. How can we undo subtracting 5?
Addition. Add 5
Yep.
to both sides.
Add 5 to both sides.
1.
Addition property of equality. It'll maintain this relationship. And then we get x is less than what?
2.
2. And then we graph it. What's to the right of 2?
3.
To the left. Circle or a dot?
Circle.
Circle. Which way do we shade?
The left.
To the left. Okay. Let's try another one. S plus 18 is greater than or equal to 21. Go ahead and try that one out. Check with a neighbor while I take a roll real quick.
Did you say this is your,
Where's class?
no, this is your unit?
Oh,
Do you guys
Yeah.
concur?
Yes.
Yeah, awesome. Let's keep going. Let's keep going. Let's up the ante a little bit. Negative 5.2 is greater than. Oh, with that in there? Yeah, I guess I do. Negative x plus 2 plus 2x.
Interesting.
We got a little bit more going on here, don't we?
Wait, what? Oh, I thought that was a 6, not an X.
Plus 2.
Negative x plus 2 plus 2x. Any ideas on what we can do?
combine the x's together.
You're right. We've got x's that are on the same side of the inequality,
Right?
right?
Just be x then.
Yeah, it sure would. So, you could do the commutative property and switch the order of these and put the x's side by side. But do we need to do that to know that they combine?
No.
I don't think so. So, we're gonna leave this negative 5.2. And what is negative x plus 2x?
1x.
Yep, 1x. We can just write x if you'd like. But what do we still have? A 2. Is x by itself yet?
No.
In subtraction property of equality? And we're done, aren't we?
No, we didn't graph it.
We gotta graph it. Now, here's the thing. Some people just do not like it when x is on the right-hand side. I'm totally cool with it. But you gotta understand that this does not say x is greater than negative 7.2. It's actually saying what? If it's on the pointing edge. X is less than negative 7.2. So you can rewrite it if you want, De'Ara, but you don't have to. Yeah, you don't have to. So if you want to rewrite it, you can rewrite it as this right here. Now when you go to graph it, what are the integers that are between negative 7.2? Negatives. Integers.
So it'd be 6 and 8.
No, 8 and
Negative
7,
6 on one
negative 8 and
side.
7. It's negative 8 and 7 because it goes 7 and
Well, but those are decimals.
it's 7. No, 7 and 8.
That would be 7.
Yeah, integers. So no decimals. No
It's
decimals.
7 and 8.
So it'd be negative 7 and negative 8. Don't you agree that negative 7.2 is between those two integers?
Yeah.
Do you guys remember what integers are?
Yes, they're numbers.
I didn't forget.
So is negative 7.2, is that going to be closer to the negative 8 or the
No,
negative
it's going to
7?
be closer to negative 7.
A little bit closer to the negative 7. And circle or dot?
Circle.
Circle, and which way are we shading?
The left.
Negative 8. Wait.
Wait, my
That's
eyes
the
shaded.
right.
That's the other way.
Yeah,
I was confused.
I get a little bit, a little bit confused there. Yeah,
I
left.
got it wrong.
It's like I was upside down. No, I wasn't. All right, let's try another one. Negative 4 is greater than
Negative 4.
x divided by 4.
Ah.
I already hear people saying it. Multiplication property of equality. You okay with that?
Yes. Oh, wait, no.
Again, it's kind of flipped, right? So how do you actually say this answer?
X is less than negative 16.
You got it? And to the right of negative 16?
To the other way.
Well, I'm sorry, what number's to the right?
Oh, negative 15.
Negative 15, negative 17. Circle or dot?
Circle.
Oh my gosh, I'm so dumb.
Which way do we
To
shade?
the 17.
I'm so dumb. I
To the
literally,
left.
I literally divided by 4.
Oh, shucks, yeah.
She already forgot angular last
Yeah.
time.
Okay.
Mine
Oh, 16. Where are you at 16?
4 times 4 times 4.
No, negative 4.
Oh, I'm sorry.
Now you guys are precise in math.
All right. Let's keep going here. Let's keep going. How about 2n is greater than or equal to negative 14? I think you guys know how to do this, so I'll be quiet and we'll check our answers with each other. We haven't had any yet, have we? I'm glad you asked.
I want some Little Caesars pizza.
What?
I want some Little Caesars pizza.
Oh, it's so good. I love Little
Big
Caesars.
cracks, it's just like little ones. that-
Okay. So, ladies and gentlemen, the special considerations. Let me show you something real quick. Do you guys agree that 2 is greater than 3?
Yeah.
Don't write this down. Just take a look for a second.
No.
Do you agree that 2 is? Wait, no, you don't agree, do you? I'm sorry. Do you agree that 2 is less than 3?
Yes.
Yeah. Okay. Well, if you were to multiply this by 2, you would also need to multiply this, right, by 2, if we do like properties of equality to maintain this relationship. And do you agree that that's still true?
Yes.
Well, or maybe you want to divide it. Maybe you want to divide it by 3. So you get 2/3. Divide this by 3, you get.
1.
Is that still true?
Yes.
Still true. Okay. But what about if you were to multiply both by a negative? If you multiply 2 by a negative, you would get negative 2. You multiply 3 by a negative, you get negative 3.
So it'd be false.
But is that still true?
No.
No. Because on a number line, negative 2 is to the right of negative 3, isn't it? So what happens is when you multiply or divide both sides of an inequality by a negative number,
The sign flips.
the relationship changes. The sign flips. So that's the special consideration, Evie, that we haven't talked about yet, is that, I'm not just, because she asked. So that's the special consideration. So take a look at this next example. Take a look at this next example. 3 is greater than negative 2x over 9. Now, ladies and gentlemen, this is written kind of in an interesting fashion here. You can think of this as 2 times x divided by 9, and then the negative of it. You could think of this as negative 2x divided by 9. You could also think of it as 2x over, guess what? Negative 9. You could also think of it as, this is a little more complicated, you could also think of it as negative 2/9 x. So it's up to you, however you, whichever way you prefer. I want you to be familiar with the fact that it can be written any of those ways, okay? Now, if you look at it this way, I would probably multiply by 9 first, or multiply by a negative first to undo that, then divide by 2. If we think about it written this way, what can we multiply by to undo negative 2/9?
9 multiplied by 9 over 2. Negative.
The reciprocal, you got it. Is the reciprocal also negative? It is. So we're going to multiply by negative 9/2. Negative 9/2.
Then you have to switch a little in.
And what did we just do? We multiplied both sides by a negative. So what's going to happen to the inequality symbol?
It'll flip the other way.
It will flip around.
And when negative 9/2 is
27.
27.
Well, so yeah, I would go ahead and just nothing simplifies, does it?
Wait, why didn't you? Oh wait.
So negative 27 over 2. What's that?
So then the sign flips.
Oh.
Wait, if you multiply by negative on both sides.
Yep. Yeah. You multiply by negative on both sides.
That was on a test.
test that I remember.
Oh.
Did
Oh,
really bad.
cool. Yeah.
I remember that they were confused negative.
Oh, guys, listen. She might have a question that you're curious about. Yeah.
So I didn't change it, I just multiplied by 9. I did it by positive 9, not negative 9.
That's fine, but then that negative would stay with the 2, and you would end up dividing by a negative 2.
Yeah.
And if you divide both sides by a negative, guess what? It's gonna flip. Yep.
But not like, oh wait, I was gonna say addition.
Right, addition, subtraction, no. Addition, subtraction, you're fine. And then over here, the negative times negative is a positive. What happens to the 2's? What happens to the 9's? What are you left with? X. Now, here's the thing. When you go to graph this,
Oh boy.
it's a fraction, right? But it's kind of hard to know where it is on the number line when it's an improper fraction like this. What might be a good idea to do to know where to put it?
Make it a
Mixed number.
Make it a mixed number. Do you guys know how to do that?
Yeah.
Oh. Yeah, I think I know.
Yeah.
13 and a half? Is that what you, yeah, 13
How do
and
you
a half?
do it?
So basically, how many times does 2 go into 27? Well, it would go in once here, and then the best you could do is 3, right? So that would get you 26 and then a remainder of 1. So it's 13 and a half.
Negative.
Yep, you got it. That might be, that's definitely easier to graph, isn't it?
Yes, it is.
So, again, what 2 numbers is it between?
Negative 14 and negative 13.
Negative 14, negative 13. Is it closer to the negative 13 or closer to the negative 14? It's in the middle. Circle or dot? Circle. And which way do we shade? To the right. That was a pretty intense problem, wasn't it?
Very.
All right. Hey, should we write down in our notes somewhere talking about if you multiply or divide by a negative? I think we should get that down. Let's go ahead and do that.
I did.
Oh, look at you. That's good note taking right there. Wow, you guys are awesome.
I'm ahead.
And drawing.
Ahead the curve.
John.
All right, so for those of you that haven't written it down yet, please write it down. When multiplying or dividing, and please include, if you haven't already, when multiplying or dividing both sides of an equation, of an inequality. When multiplying or dividing both sides of an inequality by what kind of number?
A negative number.
By a negative number. What do?
Flip the sign.
Flip the inequality. Well, actually, let's sound smarter. Can we say reverse? Is that okay? You do what you want. You do what you want.
Yeah, I think I flipped the sign because that's what my actual grade tells me.
Okay. Reverse the inequality symbol.
How do you spell sign?
Yes.
I get sing and sign mixed up. I'm like, flip the same.
When multiplying or dividing both sides of an inequality by a negative number, reverse the inequality symbol. Well, I got 2 more examples for you. 2 more.
Wait, is this just 2.2?
No, it turns out 2.2 is just doing multiplication without negatives.
It's not.
And then 2.3 is talking about negatives where you have to flip the sign. But I put them all together. I don't think they need to be separated.
Yeah.
Okay, why don't you try this one out and then check with the neighbor. Negative 5m is greater than or equal to negative 45.
So wait, why do you have to put this on?
Because the relationship is no longer true if you keep it at where it is, yeah. And basically, what's happening, Evie, is things that were on one side of the number line. Sorry, do you not like? Is that not the right name?
It's
It's Evie.
Evie, I keep saying Evie. Okay, that's tough for me.
everyone would laugh.
I know I wouldn't.
This is
Okay,
John's
so yeah, I'm
son,
sorry.
not
Evie.
John.
That's just tough. I don't know why.
Really
But so what happens is when you multiply both sides by negative, a number that was here on the number line is now over here,
That makes sense.
and then the other one's over here. So the inequality symbol,
Okay.
yeah, reverses. Yeah, John.
Okay, so if the m's on the left side where I'm sitting and the numbers on that side is the
Wait, no.
way always gonna be the way the point of the sign is gonna be facing?
If it's on the left, I think.
Like this.
Let me see what say that again.
Like if the m's here, is it just like where this is facing or how is?
Yeah, I think so.
Oh my gosh.
Yeah.
I got
Uh-huh.
I remember looking
It'll
down.
point to where you're shading. Yeah, I like that.
Yeah, like that's how I remember it, because it makes like an arrow, like
Yeah,
the way it's
okay.
going.
But it has to be on the left.
Yeah, the
doesn't it?
very
Yeah, okay. Are you guys getting, is everybody agreeing? What'd you guys get?
9. M is less than or equal to 9.
Less than or equal to 9, and were you good with the graph?
Yeah.
Did you do a circle or a dot? A dot, very good. Okay, our last one is a word problem. Yeah. So, please write this down. You earn $8.50 per hour at the sub shop.
Some way.
By the way, I don't even know what minimum wage is now.
I think it's like 860 or something.
No, 860.
I thought it was
Oh, okay. You want to change it real quick?
No.
No? Okay.
I say we change it.
No, John.
I'm changing it.
You go for
No,
it.
no.
All right, now here's what it wants you to do. Write and solve an inequality to find how many hours you need to work to buy a $187 skateboard. Sorry, it's a lot.
Gold plated.
A lot of writing.
Bro, I can buy my skateboard from Walmart. No, I'm just trying to skate. It's
They
true.
actually have longboards.
They got like penny boards at Walmart, but I would like fall and like break my ankle.
Yeah.
My dad used to skate, and he broke his wrist. My mom sold it at a garage sale.
Did you get it all down, dear? Yeah. All right. Let's write an inequality.
So wouldn't it be
Yeah.
8.50 x is less than or equal to 187?
Let me write that down. 850 x is less than or equal to 187.
No, we're supposed to be greater.
What do you guys think?
Because if it's less than 187, you can't buy it.
Oh yeah.
Oh, okay. So we want to make sure to at least have 187. Is that right?
That's
Greater
what
than.
was happening
Oh,
in my
okay.
head. It just didn't come out.
No, that's okay. Yeah.
Greater than or equal to.
Greater than or equal to. I'm with you.
Oh, I was close.
And then what do we do to solve it?
Divide by 8.5.
Divide by 8.5. What you get?
22.
Is it spot on 22?
Yeah.
Shoot bang.
Is it?
If we want to change it, but then,
22 what though? I mean, does that
22
say
hours.
hours?
Oh.
Hours.
I almost said dollars.
Yeah.
So you need $22 to buy something with 187.
So, could you work 21 hours then and have enough?
No.
No. Could you work 25 hours and have enough?
Yep.
Yeah. Is
I've worked.
everybody with me on that?
Yep.
All right. So, It doesn't say two.
Okay.
Yeah.
We have
Um,
another example?
What's that?
We have another example?
No, we
Oh.
don't. So here's the thing, it's two separate pages because it's two separate sections. So I'd like you to do page 65, 7 through 31, every other odd. And you guys realize that's not a lot of problems, right?
No.
Yeah. And then page 71, numbers 3 through 27, every other odd. You guys cool with that? And I'll double check, I think we may be ready to quiz on Monday.
Monday.
I'm ready to put it right now.
Yeah.